with part B on the midpoint rule of this problem. On Desmos, I graphed the function f of x equals 10 times the square root of the log of x. And the left-hand endpoint is 1. The right-hand endpoint is 4. And the number of subintervals is 6. So the width of a subinterval is b minus a divided by 6, which is 1/2, which is why each of these rectangles that are depicted here, each of these 6 rectangles, has a width of 1/2. From 1 to 1.5 is a half, and so on for the blue, red, blue, red. Each of those is 1/2. To find the height of that rectangle, we need to, using the midpoint rule, we need to find the x-coordinate of the midpoint, which is just going to be the left-hand endpoint plus the right-hand endpoint divided by 2. In other words, the average or the midpoint of this segment. And that's why in this little table down here, I've said that x sub 1 is 1 plus 1.5, 2.5 divided by 2. That gives me the, this is the first x sub 1 right here. I substitute that into the f function, and I get 4.723, whatever, 4.723, ... And so the area of this first rectangle is 4.7 times 1/2. And so on for the other 5 rectangles. And that's what this represents here. I'm not going to try to explain what's going on there, but we're actually summing up the areas of these 6 rectangles from I equals 0 to 5, or 6 rectangles. F of S sub I is really just the height of each rectangle, and W is the width. I could have put a W out here, the width of each rectangle. So we're calculating the area of each rectangle and then adding them together with the summation symbol. And here's the exact value for the integral, the definite integral from a to b of f of x, 26.61. So you can see for 6 rectangles, using the midpoint formula, we're pretty darn close already. Now, I'm not going to do the entire trapezoid rule here, but I will mention what has to happen. We're going to have the same subintervals, but we're going to visualize. Let me use the line tool here. These segments from here, that creates a triangle in the first, for the first subinterval. But then we go from this left-hand endpoint to here, and that creates a trapezoid. And so you have to apply the rules for the area of a trapezoid for all the other intervals. First interval is just a triangle. So there's the second trapezoid. There's the third trapezoid. The fourth trapezoid. And finally the fifth trapezoid. And remember, the formula for the area of a trapezoid is the area equals 1/2 the height times the sum of the 2 bases, or the height times the average of the 2 bases. So you'd have to find, this might be called base 1 right here. This would be called base 2. And this would be the height of the trapezoid. So the height times the average of the 2 bases would be the area of trapezoid number 1. And of course, B sub 1 would be f of 1.5. And B sub 2 would be f of 2. And so on for the remaining trapezoids. Okay, I'm not going to do anything with regards to Simpson's rule on this video. I'm going to stop recording.